Hello students, welcome to Aakash Telugu YouTube channel. So last video lo manam VBT ante enti, so asalu orbital overlap etla form aitundi, orbital overlap enduku jarugutundi, or inka types of overlaps entidi, or types of bonds enti, aa bond strength entidani cheppukunnam. Okay, ee channel lo like last video lo cheppinattu we'll see some molecules and how the bond is explained. కొన్ని మాలిక్యూల్స్ తీసుకొని సింపుల్ డయాటమిక్ మాలిక్యూల్స్ నుంచి కాంప్లెక్స్ మాలిక్యూల్స్ వరకు, అంటే వీఆర్ నాట్ గోయింగ్ టు టాక్ అబౌట్ మోర్ కాంప్లెక్స్ మాలిక్యూల్స్ లైక్ పాలియాటమిక్ మాలిక్యూల్స్ తీసుకొని విబిటి వాటి బాండింగ్ని ఎట్లా ఎక్స్ప్లెయిన్ చేస్తుందో చూద్దాం. లెట్స్ టాక్ అబౌట్ బాండింగ్ ఇన్ హైడ్రోజన్ మాలిక్యూల్. ఒక సింపుల్ మాలిక్యూల్ తీసుకుందాం. ఒక హైడ్రోజన్ మాలిక్యూల్లో 2 హైడ్రోజన్ ఆటమ్స్ ఉంటాయి. లెట్స్ సే వీ హ్యావ్ 2 హైడ్రోజన్ ఆటమ్స్ ఇన్ హైడ్రోజన్ మాలిక్యూల్. ఓకే, సో వాట్ ఈస్ ద ఎలక్ట్రానిక్ కాన్ఫిగరేషన్? Electronic configuration for these hydrogen molecules, we have 1 electron in each hydrogen molecule. That would be written as 1s1, the lowest energy orbital possible. Okay, so the ground state, that means the hydrogens are far apart and not influencing each other. So in that state we can show the electrons in orbital this way. So we have only one type of s orbital, so one block, so 1 electron each. And in the excited state, while bond formation, so we can write bond formation ani rayachu. Ee bond form jarugutunnappudu, ee bond form aitunnappudu electrons అనేవి spin కూడా చేంజ్ అవ్వచ్చు అన్నమాట. సో అందుకే మనం bond formation ని excited state కూడా అనొచ్చు. సమ్ టైమ్స్ ఏమవుతుంది అంటే ఈ ఎలక్ట్రాన్స్ ప్రమోట్ అవ్వాల్సిన అవసరం వస్తుంది అకార్డింగ్ టు విబిటి. సో నాట్ ఇన్ హియర్, బట్ హియర్ వీ కెన్ జస్ట్ సే వైల్ బాండ్ ఫార్మేషన్ వాట్ హ్యాపెన్స్, దీస్ 2 విల్ ఓవర్లాప్, these 2 electrons will overlap and the electrons will get paired. Okay, so this is how VBT explains between 1s and 1s orbital. Because s and s orbital are involved, they will be head on overlap. మన పాత వీడియోలో చెప్పుకున్నట్టు, ఐ మీన్ ప్రీవియస్ వీడియోలో చెప్పుకున్నట్టు ఎస్ ఆర్బిటాల్ ఇన్వాల్వ్ అయితే సిగ్మా బాండే ఫామ్ అవుతుంది. సో హెడ్ ఆన్ ఓవర్లాప్ వల్ల సిగ్మా బాండ్ ఫామ్ అయ్యి, సో హైడ్రోజన్కి మధ్యలో దెర్ ఈస్ 1 సిగ్మా బాండ్ ఫార్మ్డ్ డ్యూ టు ఎస్ఎస్ ఓవర్లాప్. ఓకే, దిస్ ఈస్ హౌ విబిటి ఎక్స్ప్లెయిన్స్ H2. ఓకే, అండ్ దెన్ విల్ టేక్ ఎ లిటిల్ బిట్ more complicated molecule, let's say O2, oxygen. Not too complicated, but according to our video, so the hydrogen is the simplest molecule possible, and then we have a little bit more complicated one, oxygen. So we have 2 oxygen atoms in the oxygen molecule. So the electronic configuration for oxygen atoms, okay, is 1s2, 2s2, 2p4, because oxygen has 8 electrons. The atomic number of oxygen is 8. So the number of proton equals the number of electrons in neutral state. So 1s2, 2s2, 2p4, again this is also having 1s2, 2s2, 2p4 electronic configuration. Okay, and out of which the outer orbitals are the ones which are involved in the bonding. This we didn't see in hydrogen because there is only 1 orbital here, 1 shell. Okay, and we have 2 shells with different orbitals. So outer orbitals are less attracted to the nucleus, so more susceptible for orbital overlap. Outer orbitals అనేవి తక్కువ అట్రాక్ట్ అవుతాయి కాబట్టి ఆ ఆర్బిటాల్స్ ఉన్న ఎలక్ట్రాన్స్, ఆ అవుటర్ ఆర్బిటాల్నే మనం ఏమంటాం, వ్యాలెన్స్ షెల్ అంటాం. వ్యాలెన్స్ షెల్లో ఉన్న ఎలక్ట్రాన్స్ మాత్రమే బాండింగ్లో ఇన్వాల్వ్ అవుతాయి. Okay, that is one more postulate we can say for valence bond theory. Okay, so here in the ground state, so I am writing it as GS means ground state. Okay, please try to understand that. And then we have 2s orbitals and 2p orbitals, means 2s subshell and 2p subshell. 2p subshell contains 3p orbitals, and 2s contains 2 electrons, and then 2p contains 4 electrons. So fill the electrons by following Pauli's exclusion principle, Hund's rule and Aufbau's principle. Okay, so first the electrons are written, okay, are filled in the degenerate orbitals, and the electron pair starts according to Hund's rule. Okay, pairing of electrons starts. and then we have 2s again and contains 2 electrons of this oxygen, and 2p, we have 4 electrons. Okay. Now according to VBT, only half filled orbitals are involved in overlap and forms a bond. Okay. So which are the half filled orbital present here? Okay, let us say according to the convention we must have sigma bond started first. Okay, so this is one thing I forgot to say, that so sigma bonds can exist independently without formation of pi bonds, but so this can exist independently, but the pi bonds are dependent on sigma bonds formation, dependent on sigma bond formation, sigma bond formation. ఓకే, ఒక సిగ్మా బాండ్ ఫామ్ అయితేనే ఇంకా హెడ్ ఆన్ ఓవర్లాప్ పాసిబిలిటీ ఉండదు కాబట్టి ఒక పై బాండ్ అనేది ఫామ్ అవుతుంది. ఓకే, సిగ్మా బాండ్ ఫామ్ అయిన తర్వాతనే పై బాండ్ ఫామ్ అవుతుంది. ఓకే, సో ఖచ్చితంగా ఒక సిగ్మా ఇంటరాక్షన్ అనేది ఉండాలి కాబట్టి ఈ పిఎక్స్ పివై పిజెడ్ని మనం ఇట్లా రాసుకోవచ్చు. లెట్స్ సే దిస్ ఇస్ పివై, దిస్ ఇస్ పిఎక్స్ అండ్ పిజెడ్. సో పివై పిఎక్స్ అండ్ పిజెడ్. సో ఇక్కడ చూడండి, we have 2 p orbitals which are free for orbital overlap, which are half filled. Okay, so exactly matching the overlapping condition of VBT. So the first 2 pz orbitals from each oxygen atom will overlap head on. Okay, so this way, so let's say this is the pz orbital here and this is the another pz orbital. So they will overlap and forms a sigma bond. Okay, sigma bond. And whereas the other p orbital, because already one head on overlap is there and the electron densities are above and below the internuclear axis, so they can sideways overlap, the px px. Let's say this is pz pz and this is px px overlap, forms a pi bond. So this will be resulting in the formation of a pi bond. So between 2 oxygen atoms we have 2 bonds, and the first bond formed would be sigma bond. Okay, and the second one would be a pi bond. So this is how VBT explained the formation of 2 bonds between the hydrogen atoms, and the pair of electrons in the 2s and 2p will be there as lone pairs. We have in 2p y we have 1 pair of electrons, and 2p's 2s orbital we have 1 pair of electrons on each oxygen atom. Okay, so this is how the bonding in oxygen has been explained according to VBT. ఓకే, సో ఎప్పుడైనా ఒక డబుల్ బాండ్ ఫామ్ అయింది అంటే ఖచ్చితంగా ఒక ఒక సిగ్మా బాండ్ ఫామ్ అయ్యి దాని తర్వాత ఒక పై బాండ్ ఫామ్ అయింది. ఓకే, సో ఇన్ డబుల్ బాండ్ వీ హ్యావ్ 1 సిగ్మా బాండ్ అండ్ 1 పై బాండ్. ఓకే, రైట్. నెక్స్ట్ విల్ సీ a little bit more complicated, means not so complicated, little bit more. N2 molecule. Okay, it's very similar to O2 molecule, but there is a drastic change in this. Okay, so we have the nitrogen molecule contains 2 nitrogen atoms, and if you write the electronic configuration we can write, so we have the atomic number 7 for nitrogen just before oxygen, 1s2 2s2 2p3, here also 1s2 2s2 2p3. Okay, now in the ground state, so it will involve the 2s orbitals and 2p orbitals which are attracted less towards the nucleus in the bonding compared to 1s orbitals. So the valence electrons, the 2s 2p or 2p electrons are involved in bonding. We have 2s 2 electrons, 2p 3 electrons, 2s 2 electrons and 2p 3 electrons. Now you can see there is a possibility of overlapping all the p orbitals. Let's consider px py pz. So this will also be px py pz. Now again the pz pz overlaps and forms a sigma bond. So in the ground state it is, and in the excited state or in the bond formation, excited state mostly we will use for polynuclear atoms, but we can also use the bond formation state while the bond is forming. Upon bond formation, so what happens, pz pz will head on overlap and then py will overlap with py. You can see that here. This is pz orbital, pz pz orbital. So it's positive overlap and forms a bond, which is forming a sigma bond here, and then you can see, let's say this is px, px are overlapping, sideways overlap, one pi bond is formed, okay, and py overlap, so will result in another pi bond, okay. So there are the p orbitals are mutually perpendicular, so the electron density generated or formed due to the overlap also mutually perpendicular to each other. So what we can see here, we have two nitrogen atoms contains 3 bonds between the two nitrogen atoms, and the first one would be a sigma bond and the other two are pi bonds. So there can only be one sigma bond, there is only one head on overlap between two atoms. One more overlap between two atoms results in the formation of a pi bond. So in a double bond we have a sigma bond and a pi bond. In a triple bond we have one sigma bond and two pi bonds, okay. So this is how we will explain the bonding, and we have one lone pair of electrons, so between two nitrogen atoms, okay, that is there in the 2s orbitals, okay. So explaining diatomic molecules, okay, is easy in terms of VBT, okay, but so when it comes to polyatomic molecules it may deviate, it may assume even more things, okay. So in the excited state we can write this excited state, nothing but you do not have to show this, but you can just write overlapping of orbitals this way. So we have 2s and the 2p and 2s separately, and 2p and 2p will overlap, okay, the 3 electrons, or we can write it here itself, not a problem, you can write it separately or you can write it this, okay. Then we will see the limitations of VBT, okay. So limitations of VBT, limitations in the sense what are the drawbacks and what it cannot explain. See, all the molecules or any compound, okay, we are talking about molecules here, so we can say molecules or any species, molecules here we can tell any species which has, I mean according to the magnetic properties, basically would be classified into two types, diamagnetic and paramagnetic. Okay, diamagnetic in the sense the molecules or the species will not be magnetized under the influence of a magnetic field, whereas paramagnetic will be influenced or will be magnetized under the influence of a magnetic field, okay. But molecules ni చూసి ఎలా dia and para అని చెప్పగలం అంటే, so if in case all the electrons are paired in a molecule while bond formation, then it would be diamagnetic, whereas paramagnetic means at least one unpaired electron is present while forming a bond, okay, between two atoms, then it will be considered as a paramagnetic molecule, okay. So in that case if you talk about O2 molecule, okay, according to VBT you can see in the previous slides, O2 molecule all the electrons are paired here, you can see this will be overlap. In the excited state what happens, the 2p orbitals, the pz will overlap and the px will overlap, okay, this way and forms a bond. So these electrons will get paired, you can see all the electrons are getting paired here, all the electrons are getting paired, so this will also be paired. So all the electrons with its two lone pairs and two bond pairs, all the, so we are saying it as pairs, I mean two lone pairs on each oxygen, okay, that means 4 lone pairs and 2 bond pairs are all paired. So oxygen is considered to be diamagnetic according to VBT, diamagnetic according to VBT. VBT says oxygen is diamagnetic, but it is experimentally found oxygen is paramagnetic. Oxygen is paramagnetic. It is experimentally found. Okay. oxygen is paramagnetic. So, this paramagnetism of oxygen cannot be explained by VBT. So, that is a main drawback of VBT, and also so it cannot explain the geometries or shapes, geometry and shapes of molecules. So, it talks about how orbital overlap occurs, how the bonds are formed, but it didn't say how they exist and gives a shape or geometry to the molecule. And majorly, while talking about hydrogen, nitrogen, oxygen, we didn't assume so many things. Okay, but when it comes to polyatomic molecules, okay, VBT cannot explain completely, cannot explain the molecule bond parameters and overlapping, okay, whatever the results that are found experimentally, without the inclusion of hybridization, So, hybridization is such a topic that is found to complement VBT, to explain, to increase the effectiveness of VBT while explaining a polyatomic molecule. Okay. So, in the next video, we will see how hybridization occurs and what is the reason for hybridization to happen. Okay. So, why it is included in VBT. Okay. We are not going to see completely the hybridization in that video. Okay, we will watch the hybridization videos later on. Okay, but we will see how hybridization occurs and why it is occurring. Okay, in case of a polyatomic molecule. So, thanks for watching. Please like, share, subscribe to Aakash Telugu YouTube channel.